Good afternoon, good evening, and good morning from wherever you're joining us from today in the world. My name's Sarah, and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to a Microsoft Reactor Sydney live stream event and another episode of our Devs Downunder series. Today, I would like to welcome and have honor to join with us Lana Vishnivetska. I'm sorry if I said that wrong, Lana. Lana is currently the technical lead at Challenger. She has 20 plus years of experience in software development and IT, architecture, SecDevOps, cloud and people management. So today's session, she will be discussing with you SecDevOps for Azure Functions and APIM in hybrid cloud architecture. You'll see I've added to the comment section today our check-in link with the event code 14124. So please check in for today's session where you'll find additional resources provided by both Lana and the Reactor. We will be speaking for about an hour today with 10 minutes for questions at the end. However, do send us your questions throughout in the Q&A or the comment section and we'll answer as many as possible towards the end. At the conclusion, I'll also share with you a link to our feedback survey with the same event code 14124. So if you have time to do that before we finish for today's session, that'll help us curate our future topics and much appreciated. You'll also see we are live on YouTube right now, so there will be an on-demand version available of this straight after today on our YouTube channel, and I've provided you with that link as well in our Q&A section, and if you check in, you'll also find the link to the YouTube channel there. But for now, I'd like to hand the floor over to Lana to begin. So thank you, Lana, and over to you for today.
Thank you, Sarah. Good afternoon. Today I will be talking about secure DevOps for Azure Functions and APIM in hybrid cloud architecture. Where do you start? Cloud services offer more flexibility and freedom, but it also creates a huge blind spot for security. Popularity of serverless applications comes with their own challenges. We have multiple APIs and microservices architecture, and it doesn't make security simpler. Agenda for today is I will give you a brief introduction who I am, and we talk about cloud application security, technical controls, and administrative controls, and I will show some demos. As Sarah mentioned, my name is Lana Vishnivetska, and I'm technical lead in Challenger Australia. And my passion is web development, .NET and .NET Core, cloud, and application security. So you can reach me on my Gmail, or you can find me on LinkedIn simply searching my name. Azure Functions Overview. It's a serverless solutions and system application logic implemented as ready to execute blocks of code. These blocks are called functions. Serverless computing means providing backend services compute resources on application demand. This model lets developer focus on the functionality rather than on infrastructure provisioning and maintenance. It helps build features faster and reduce time to the market. It also allows some flexibility. As number of requests increase, as many resources and instances as necessary allocated. As requests fall, resources and instances dropped automatically. So you can choose your own hosting plan. There are 3 basic hosting plans in Azure for Azure Functions: Consumption Plan, Premium Plan, and Dedicated Application Service Plan. All hosting plans are generally available on both Linux and Windows machines. The hosting plans dictate the following behavior: how your application scaled, the resources available for each function, and support advanced functionality, for example, Azure Virtual Network connectivity. API management is a gateway between clients and backend services. Allow companies to publish API to external and internal parties. It provides a central place to consolidate and manage thousands of APIs across multiple platforms. Definition by Microsoft. It accepts API calls and routes them to your backend. Verify API keys, JSON Web Tokens, certificates, and other credentials. Enforce usage quotas and rate limits. transform your API on the fly without code modifications. It allows you to cache backend response and log call metadata for your analytic and security purpose. Building facade and decouple between internal backend and external services, or to allow third-party partners, provides better security and protection for your APIs. API management security baseline defined by Microsoft and should be implemented in collaboration with your technical engineers. As an application developer, you should take care about following: protecting critical web applications. So you should configure your API management within a virtual network in internal mode. And you should apply Azure Application Getaway and configure this on top of your APIM. By using this gateway, developer can control access to critical web applications. You also should deny communication with known malicious IP addresses. By using Application Getaway, developer can prevent access to malicious IP addresses. Role-based access control should be used to restrict access to API management. And also, API management allow following capabilities: Azure products. Products, how APIs are surfaced to developers. Product can have one or more APIs and configured with a title, name, and description. It can be open or protected. With the protected products, you need to subscribe before you will start using them. When you subscribe, user get a subscription key, which is good for any API in this product. Groups are used to manage visibility of products to developers, can be administrators, developers, and guests. As you can see, Azure API Management provides many security and performance features. For example, it can limit the number of calls to your API. It can help you to prevent denial of service attack by using throttling. And it helps you to secure your backend using subscription keys. It also allows advanced security policies like JSON Web Tokens, certificate, and other credentials. In a hybrid cloud, my personal experience was with ExpressRoute circuit. And as you can see in the picture, ExpressRoute allow you to connect with a Microsoft through the edge routers, where you have your gateway subnet and web tier, business tier, and data tier. And it also connects to your on-premises network, where you can keep your, for example, SQL Server on premises, or other components. Serverless applications. You have no servers. Does it mean no attacks? Actually, it's not the case. Threats for your applications are still there. They just look and act in different way. Serverless applications can include hundreds of functions, meaning your attack surface has changed. These days, the overall shift of responsibility with hybrid cloud architecture resembles cloud provider and cloud customer. So cloud provider responsible for physical security, host infrastructure, operating system, and a logical application server, where cloud customer should take care about application logic, client endpoints, and data. And controls shared between them are network controls, identity, and access management. To keep control and maintain security requires high maturity level. And secure DevOps is a cultural thing, shift in a way of thinking. As you can see, there is plenty of things we need to be responsible for. OWASP top 10 security threats. They still apply for serverless applications and hybrid cloud architecture. To help you to streamline and bring your security on high maturity level, make a right grouping for function apps. And grouping means collection of functions which share code, configuration, or management. And this allows you to give a least privilege to your functions. Leverage any security features built by your cloud provider, for example, Azure Security Center or Managed Identity. Later in this talk, we discuss application firewalls, restriction of IP addresses, and what tools you can use in your CI/CD pipeline, and how to shift a mindset and align practices with secure DevOps model. Communication and more. Trust security model, security development lifecycle, and know your stakeholders. This is a combination of technical and administrative control, where your zero trust security model aim to wrap security around every user, every device, and every connection all the time. With user, you start with identity and access management. That's the first step in enforcing security policies. With applications, you should grant least privilege, and it's regardless on-prem or in the cloud. All private applications and accounts should be covered. Zero Trust is security framework. And when it comes to the network controls, the enterprise resources and data need to be segmented and continuously monitored for intrusions and anomalies, where anomalies is not typical behavior. And the last is devices. End user devices must be isolated from each other and protected from threats, and continuously monitored, of course. For software engineers, it means to protect resources and applications rather than network protection. Security development lifecycle is a little bit different from our normal software development lifecycle, where you can integrate security into DevOps. It starts with your plan, where you need to assess your threat model and build your policies. When it comes to the code and implementation, here static analysis should be performed, which means tools integrated in your CI/CD pipeline. After the code review, when you build your application, it is recommended to bring your penetration testing earlier. In traditional model of DevOps, we do our penetration testing at the very end. But in secure DevOps, you can start thinking to bring this even before you go to production, for example, on staging environment. After you completed your test and ready to release your product, think about compliance validation. And when it comes to the deploy, your log and audit should be there. When your application became live and operates, you still think about your threat intelligence and continuously monitor to find defects and then to do proper response. So the last step is monitor, and your next project start pretty much with the same, with a plan. Know your stakeholders. Who are your stakeholders? If it's a business division, so what's the level of knowledge and security they have? Start small and plan to scale. Work with Agile. It doesn't work well with a waterfall approach where everything should be estimated and budgeted upfront. But you can take any opportunity as you can to talk to your stakeholders and embrace your idea. You can start educate them and basically to develop why and how cybersecurity will help business to succeed. You should define what security controls require. Start early in a project discovery phase and do upfront security assessment. Invite professionals if you don't have capability to do so. Be an enabler and build a knowledge base for everyone, from the basic knowledge to more advanced users. General security guidelines for application developers consist you have to validate Azure Functions input and apply least privilege principle, designating group of individual roles responsible for specific function. Monitor your third-party dependencies. Take components only from official sources over secure links. It's especially important when we have lots of new GET packages available on the market or NPM packages. Prefer signed package to reduce the chance of including a modified malicious component. Secure your cloud storage. Add multi-factor authentication and data encryption and your SaaS tokens. If you keep your client documents in blob storage, for example, then leverage shared access signature tokens. That type of secure tokens grant privileges to your application, to Azure storage resources. And these tokens also valid for short time. Enforce your authentication and authorization. That's in line with zero trust model identity management. No direct access calls to Azure functions, only through API management endpoints. Secure network security rules for inbound and outbound communications. And configure transparent data encryption. That's especially important in hybrid architecture where your SQL Server databases are on-prem. What are subscriptions in Azure? It's a logical container used to provision resources. It holds details of all of your applications like virtual machines, databases, and more. We have Azure Tenant, Azure Subscriptions, and Azure Resource Groups. Azure Tenant is the highest level of Azure subscription hierarchy. This is represented as a single identity, for example, person or company. Tenant is linked to a single Azure ID instance. One tenant can have multiple subscriptions. Azure subscriptions is at the level where customer build upon of usage. So it also provides logical segmentation for simplifying administration and access, and it also groups your billing and send invoices. So you should design these subscriptions having security considerations in mind and align with a segregation of duty approach. Typically, company have single tenant and several subscriptions, and each department can use their own subscription to access Azure resources. And Azure Resource Group will help to create logical and billing segmentation for resources again. Each resource group can be given different administrative privileges to track billing or access. And what are types of Azure subscriptions? Sponsored or trial subscription, access to certain resources provided for limited periods of time or for certain amount of credits. Pay-as-you-go Azure subscription is the most popular, where it's more affordable type of payments. And enterprise agreement Azure subscriptions, these are high volume of usage and it requires certain level of commitment. Today we talk about API management subscription key and how they can be used to protect your Azure functions. Think about subscription as API key. Client must have valid subscription in HTTP request when they are making calls. You provide the name of subscription, set the scope. Is it API or individual API, all APIs, or product? And you should restrict access to subscription keys on staging and production. So only authorized party can have an access and have a look. Let's go to Visual Studio and see how can we design our resource management template to include subscriptions. You have your parameter file where you specify APIM instance name. That's for development, for example, APIM-dev-mg. And another one, APIM instance name, can be specified for UAT. Similar you do for staging and production for different APIM instance name. And here we go to subscription, where you basically allow your API1 to access your API. You can define scope here. I define this as internal. And here API2, granting have a subscription to my API through the internal scope. And similar for third API, where I can grant access to my API. And in your ARM template, you create subscriptions for APIM by specifying service connection, and you have inline script here where you create a deployment group and include your subscription JSON. Next, how to protect your subscription keys and do not expose them to entire development team. You can take an advantage by using segregation of duty model. So what is the segregation of duty model? It's a concept of having more than one individual which is required to complete a task. This is internal control and this is administrative control, which is intended to further reduce risk of fraud and reduce security risk. Sometimes it is known as a redundancy. General approach, purpose, and principle of segregation of duties model. Privilege are divided among multiple professionals, so there is no single dependency and no single individual to proficient to control the whole process. By allowing more than one individual to complete the task, organization can minimize an opportunity for misconduct or fraud, unintentional error, and security breach, and also increase an opportunity to identify this. The key principle that can be applied to segregation of duties are sequential separation when activity is broken into the steps performed by different person. For example, deployment to UAT can be done by developer, but deployment to staging and production can be done only by authorized person from security team or from SecDevOps team, for example. And individual separation, when at least two person must approve activity before it go live. For example, release governance process, when it comes through the few steps and through different stakeholders or IT owners. So segregation of duties, how it aligned with continuous releases. How it's aligned with Agile and how you can maximize efficiency, reduce time to the market, and unnecessary costs. Separation of duty works well with continuous approach only under different conditions. It certainly creates difficulties for secure DevOps and for software engineer team when some limitations are present. In general, it depends on your company culture and how your release governance process is built. If you have formal release process where you have few days which comes from change request to the actual deployment, then segregation of duty is a perfect model for you where you can benefit the most because you can go through the stages with different people. But from the other side, and it based with my personal experience with different companies, especially in the e-commerce, when continuous releases are practiced, then segregation of duties is a suboptimal model because if you need to go to production few times per day, you basically cannot wait for different people to do job for you. So it creates an overhead. The types of companies will basically assess their risk appetite and security posture, and they definitely go to production faster and reduce time to the market. Still possible when SecDevOps team controls your CI/CD pipeline or controls the last step of your production deployment. But decisions should be made by you and it based on your individual situation. JSON Web Tokens in Azure Resource Templates. Secure your backend using Auth2 protocol and JSON Web Tokens, and validate these tokens against well-known endpoints in your identity provider. You can also extract token claims in Azure API management policy. It's easy to validate. And you also should check expired registered claim if it's included in a token, unless require expiration time attribute is specified and set to false. This is an example how to validate your JSON Web Token against your issuer and well-known endpoint. So policy requires an OpenID Connect Discovery endpoint to be specified via an open config element. API management expects to browse this endpoint when evaluating the policy and include these JSON Web Token URLs in response to discover publicly accessible key modulus and exponents pair. If you implement a custom auth protocol and your own identity management solution, it is recommended to implement OpenID Connect endpoint, OpenID discovery endpoint. Let's have a look on example. There are policies, and this is how you extract value from your JSON Web Token. So you can have a few validations beforehand where you check if your validation key present, then you can reject these. This is an example for your sign-in endpoint for where you can throw unauthorization exception if your API do not use a bearer authentication scheme. So here, when it comes to parsing, you can try and parse your JSON Web Token in order to get, for example, user ID or customer ID from your custom claim or roles, again, from your custom claims. So you get in them and then you pass them down to your Azure functions when, for example, customer ID can be an input parameter for your function. And you reject this request if it doesn't go well with the conditions and expected. So here in this configuration parameter file, you can specify your origin and CDN endpoint and your development environment URL. Same for UAT, and you can do same for staging and production. Certificates is another option to help you to tighten your security posture and bring additional controls, security controls. There is a capability to protect APIs using client certificates. You have two options. You can keep your certificate in Azure Keyword, or you can upload the certificate directly to API management, and then you can keep this certificate thumbprint in your keyboard, and in your ARM template, you can extract here and validate. Examples here illustrate a certificate uploaded to APIM directly with a thumbprint kept in Azure Keyword, and validation of this certificate done in C# code by implementing custom validator. Azure Keyword is a tool to keep your secrets safe. You can keep your subscription keys, API keys here. You can keep connection strings if you have database on-prem. So you can put your connection string in Azure Keyword and then use this Keyword ID in your ARM template to get this value. You can keep other secrets, such as password and client's IDs, client secret. As a general tip, never leave valuable information in the source code, configuration files, and README files. As been mentioned, different type of Azure functions require different security measures. And for example, connection string is one of them if you have data transformation job. Pipeline as a code, and why everything should be source controlled and no manual changes should be made via Azure portal. That's another technical control which you can put in place in your software development lifecycle. Let's start from the distance. For every project where we apply secure DevOps model, we do upfront assessment, where we do initial risk assessment and our audit compliance, what controls needs to be enforced and our boundaries. Threat modeling, where we assess risk in iteration, where we can define our attack surface, identity management, access software supply, access controls, and software supply chain. Your delivery pipeline also here with repositories, NuGet servers, plugins, artifacts, and connections. Keep your delivery pipeline configuration, which builds, deploy, and test applications, where software infrastructure also treated as a code under source control and represented as reusable components. You have security of the pipeline and security in the pipeline. Security of the pipeline means your permissions, version controls, transparency, and consistency of deployment. Pretty much one location for all. And the security in pipeline means vulnerability scans, peer review, access to related resources, approval of every development step by relevant authorities. Related to secure DevOps, where you can incorporate security as a code methodology as well. For example, reference key vault ID in your ARM template instead of putting value. And a second example is to implement security scans in the pipeline. And please note, this practice is not only relevant for Azure functions or your backend APIs, but you can use them in the micro frontend as well. Application firewalls. It's used in conjunction with Azure Application Getaway. You can configure API management service in the virtual network in internal mode and make it accessible only within the virtual network. So if you will have a look on Application Getaway on the right, your WAF sits here and your valid request going to your websites, which prevents XSS attacks and SQL injection attacks and only allow valid requests. If you have internal and external endpoints, you can separate them logically as well through the application gateway, where your external customers are coming to your service endpoint and then to application gateway, which sits inside your application gateway subnet. This bit is a virtual network where you can define your subnets inside this, and you have another service endpoint for your internal customers who are coming to API management in internal VNets. It provides you and gives you a centralized protection for your web application from common exploits and vulnerabilities. Web applications are increasingly targeted for malicious attacks that exploit common known vulnerabilities. SQL injections, they're still there, cross-scripting, and they are most common attacks these days. By combining API management provisioned in internal virtual network with application gateway frontend, you can use the same API management resources for consumption by both internal and internal consumers. And you can use a single APIM resource and have a subset of APIs defined for available for external customers only, for example. And you can switch your access to public internet on and off. Azure Monitor. That's a consolidated place where you can see reports for all Azure entities and on-prem ecosystem. Best practices are enable monitor for all applications, integrate monitoring into the pipeline, group services and resources into a resource group, retain logs for audit and compliance purpose. In other words, it's a solution to monitor health of your Azure applications and manage secure hybrid cloud resources as well. It is a platform to monitor both your Linux and Windows virtual machines and their health, and you don't need to log into a machine to see what's going to investigate some network or application issues. It has some advantages. It allows advanced analytical engine and rich interactive query language for your queries. Automatic notifications and responses to critical issues. For example, you can create rule and alerts around different conditions and data collected. And it also comes in optimum costs. Information of security events will help you to understand and prioritize your security threats based on what happened in production. Here you can see an example when someone probe and test your Azure application endpoints in order to get an access. So that's basically an attack. Watching runtime errors like this, for example, 404, will give you an understanding what's an attack signature. And it will show you where your application been probed and tested, so you can apply additional controls and additional protections. You can also think about other tools available for Azure functions. For example, Serverless 360, Application Insight, Service Bus Explorer, and Log Analytics. Let's have a look on metrics alert and how to configure them. So basically here you have metric alerts created via template, where you can specify your criteria. For example, if backend duration is greater than this number, you will have an alert, or you request some greater or equal, you will have an alert too. That's your logs. Where response code is different, basically like 400, and you want to check time generated for these and count. So you can be flexible with your conditions, and you will start getting alerts coming onto your email specified. That's quite interesting topic, application security testing. As been mentioned, you can include static application security testing in your code, but there is more. Not only static application security testing, but dynamic testing and interactive analytic analysis security testing or hybrid model. Anytime when it comes to web application development or scheduled functions or ETL job, we need to think holistically how to combine this approach and how to benefit most to improve OWASP top 10 security vulnerability detection. You can start with the basic, like fixing known vulnerabilities and hardening your system to decrease some likelihood of getting attacked, as well as implementing runtime protection. Static development security testing, static application security testing, can be incorporated in your pipeline, in your coding for every commit. And this will help you to catch defects early, and will show you known and obvious pattern of vulnerabilities in the source code. Although we should be careful how to set up these static tools, because they known for quite a lot false positive results and warnings, where even minor unexploitable defects are highlighted. However, it will teach your developer to how to use security patterns and how to avoid insecure, infrequently patched code libraries, for example, and explains how to repair potential vulnerabilities. Where dynamic application security testing is more suitable for waterfall approach, but agile can benefit from this too. This helps you to find vulnerabilities against your running instance of the application by simulating the behavior of attacker. And these DAST tools, they do black box testing. Interactive analysis security testing will use agents. And these agents are running and or you have additional servers libraries to collect data from running instance of your application, which can help you to reveal vulnerabilities. It works inside the application and different from static and dynamic scans. It doesn't test the entire code base or entire application. It will test what you will tell it to test. It runs as an agent with scripts to allow you to collect data and later on analyze these event data. You can have real-time reports for scope of the applications. You can save these uh, basically test cases for later. You don't need to write them all the time, but you can repeat them as often as necessary. And it is really good for your Azure functions and API testing. In most cases, it is sufficient to use static application and dynamic application testing. However, there is a new approach like hybrid application security testing. You can you can benefit from combining results from SAST and DAST tools and prioritize them by from severity and criticality. So you will start fixing vulnerabilities which matter most, and then you will go and find your efficient approach to application security testing. There are many vendors on the market you can use, Sonatype, Nexus IQ Server, and many more. And penetration testing also can be included on different stages when you're ready, not only at the end when you're ready to go to production, but even when you are on staging. Incident response procedure. As been told, secure DevOps model based on shared responsibilities. At the end of the day, this is a team responsibility. Security comes first and integrated in every stage of software development lifecycle. We should remember that failure is going to happen. So here we can start assess our risk appetite and our level of tolerance. Open, blameless communication, not only inside security team, but also for application and software engineers, will help you to improve communication across team and get right people start working if breach occur. So your incident response model should be prepared in advance. Preparation is the most crucial step where you ensure your staff and stakeholders trained regardless different security breaches and incidents. They have their own response roles and they know what to do in case if breach occur. And you also implement security breach drill scenarios where they can execute mock data breaches, for example, on regular basis, but you can plan and fund these in advance. Identifications, that's where you determine if you've been breached. It could originate from many different areas. When, how it was discovered, and who discovered. Are the areas impacted, and what's the scope been compromised, and does it affect operation point of entry? Containment. Do not destroy evidences, but contain the breach so it doesn't spread and disconnect affected devices, for example, or applications or servers. Prepare short-term and long-term strategy for containment. Eradication. Fix the root cause of the breach. Has your system be patched and hardened, and what kind of updates been applied for your code, and has your code been fixed? Next stage is recovery. When you're restoring and redeploying your application. And lessons learned. Think about rapid learning if incident happened. It's a really valuable practical experience. Better don't have these, but what if it's occur? So every occurrence will help you to tighten your security posture and put additional security controls. Post-incident review meeting will help you to identify and evaluate cost and reputational damage. What weaknesses been exploited? How to ensure it's not happened again? What changes required in your secure DevOps cycle, or maybe you should apply these on enterprise level? These are all points for today's talk. And now back to Sarah, if she has any questions to me. Thank you for your time.
Thanks, Lana, and thank you for presenting. I'll just check if there are any questions that came through, I think from our other platform. Bear with me. Okay, so we had a question come through from Nathan. He says, can Key Vault be used to secure items like certs key on a private cloud or on-premise infra?
You definitely put your certificate thumbprint here. And as another option I mentioned, you can upload the whole certificate. And then in your ARM template, you can take Key Vault ID to reference this certificate or thumbprint and validate against it.
Great. And another one that came through as well from Nathan was, what rules come in built into APIM, or do we need to code all the rules?
What kind of rules we're talking here? If there are metric alerts, you definitely need to build them yourself, because it depends what you want to see and get as a response from Azure. And resource template for Azure APIM is quite flexible, so you can put quite a lot here. For example, even your third-party providers and vendors plugins can be configured here and installed. You don't need to install them manually on your APIM. You can put them in ARM templates. So yeah, it's quite flexible. I don't think we have some kind of pre-configured ARM templates. So my vision, it's your responsibility to put your code and configuration here. Yeah, because it's different. Everyone have different on-prem configuration or hybrid or just a cloud configuration. So yeah.
Great, thanks, Lana. So that's actually all of our questions that came through for today, other than somebody asking about the links for today. So we can put those ones in the check-in link for you. You'll see the link at the top there with the event code 14124. So if you just head to that check-in page, you will be able to find the additional resources there. And I'm just about to share with you the link to our survey, so if you have a moment to fill that out with the same event code, that would be great. But otherwise, you can find the link to the YouTube channel via that check-in link. We've had one more question ping through, so I'll just read this one out. It says, how does this DevSecOps would help to system administrators? So how would DevSecOps help system administrators, I think, is the main question.
Okay. I can see for the last couple of years, the roles a little bit mixed these days. I can see, for example, 5 years ago, you can see pure network engineers and system administrators working on their own tasks, and I can see developers working on their part. But here, for the last couple of years especially, I can see roles are mixed. And if it was pure DevOps engineer or administrator in the past, now I can see the necessity to share this role a little bit with developers, and it definitely helps when it comes to system administration, when you can see where your possible vulnerabilities and breaches might be and what security controls are missing. I believe it will help to reveal security issues earlier, on a low level. When it comes to network engineering, for example, security starts as a cybersecurity discipline when you use protocols and basically physical security and uh, channel and protocol security. But it also helps to be more aligned with a software engineer team where applications developed. So I think it all comes to better security posture across the organization, not across the role. Because if we making roles and responsibilities shared and broader, it basically makes everyone's life easier when we find our problems earlier on software development stage rather than at the end or live when your application is live. It's a broad topic. If you think there is something for me to add, feel free to add and send me more questions on Gmail or LinkedIn to specify what exactly you want to hear or what exactly you want to discuss when it comes to system administration.
Thanks, Lana. And just one more question did come through, which we have time for. It said, you mentioned including security checks within your pipeline. What tools can help prevent a SolarWinds hack scenario?
I use a Sonatype and Nexus IQ server, and this vendor has some policies which you can configure around this, and they're pretty good with catching that type of issues. I'm sure there are different vendors on the market where we can basically do due diligence procedures and see what kind of vulnerability they are able to find and to catch. From my best knowledge, many of them, many vendors, they do catch that type of issues.
Awesome. So I think that's it from questions today. Thank you for answering those ones that came through, and thank you to everybody for interacting with us in the Q&A section and for tuning in today. As previously mentioned, just the check-in link there with that code 14124, the same one can be used for the survey, and you'll find the additional links in that check-in page. Thank you to everyone. Have a good rest of your afternoon, evening or morning, and thank you again to Lana. We hope to have you back again with Microsoft Sydney.